Welcome to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. We have been working on the Sword Familiar, and I think we'll do a little bit on the Sword Familiar, and if we can't make any more progress today, then we can look at some of the other overlays that I haven't taken a look at yet. There's quite a bit that's new that other people have begun to import. That would be good to just for me to familiarize myself. If you're not familiar with the Castlevania Symphony of the Night decompilation project, go to soten.z.dev where you can learn more and see the overlays that we've been working on. I'd say we're somewhere between 15 and 25% of the way through the overlays that have been started for the PlayStation version of the game, much less so on other versions of the game. And to aid in some of the Sword Familiar decompilation that we're doing today, I might look at the HD version of the game, which I don't think we've looked at on the stream before, and I've only looked at briefly myself. On soten.z.dev, you'll also find a link to the GitHub repo where you can find all the code that's been decompiled so far, and you can find a link to the Discord server where we are chatting about it. And it's been a little quiet lately. A lot of people, I think, wrapping up school years and holidays and all kinds of other stuff. So get in there and start chatting. I really appreciate everybody who shows up to chat each day. It's a lot of fun having people on, answering questions, and just going through this process with anybody who enjoys it. So let me pull up. There's 4 functions, same as yesterday, 4 functions remaining. I went through and got everything ready as best I could for a PR, and then decided to split up the PR into multiple sections. So I have one PR where things from previous decompiled functions that had to change based on data types that were learned about from new functions. I sent that one out this morning. I think the next one will be the data decompilation. I finished doing that yesterday, and so all of the data and BSS or uninitialized data is also finished for the Sword Familiar, so when that gets checked in. So really it's just these 4 remaining functions and then any data type switches that need to be made. Morning, Orkim. Good to have you. Hey, if you're here, that's good for me. And I just am glad to have people following. So thank you for joining in. Oh, hey, Blue Harvey. Thank you. Yeah, we'll see how this one goes. This one's going to be a little harder. And I'm not sure if we'll make much progress. We should make a little bit of progress. So, like I said, I think we're going to work on... Oh, not this one. It's not the one I want to work on at all. There's 2... basically, I want to focus on E84, which is full of macro function style macros that have a lot of just inline assembly for calling the GTE coprocessor and doing other things like that. And so what's nice about the PSP version of this function is that all of those GTE macros become function calls, and we can pretty clearly see what each of them are doing and what their args are and things like that. There's a few differences for, and now I'm going to forget the mnemonics for these, STDP and ST set flag. Those are a little different. But other than that, they're pretty similar. It actually might be interesting to go look at the function. Those call kind of a stub function that take no arguments. It might be interesting to look at that as well. If we can't make much progress, I'm going to pull the HD version of this. HD, we believe, stands for hard drive which is a development build that is found on the PSP version of the game. So I'm going to just refamiliarize myself with this. I haven't looked at this since I think last week when we were working on it. And I just want to go through and clean things up and figure out if there's any obvious changes that can be made along the way. I like getting rid of as many of these. So M2C, when it decompiles, it's going to throw basically every new register use. Every time a register gets set, it's going to create a new variable for those things. And so I want to go through and get rid of as many of these as I can after we've cleaned those up. And if there is questions or comments along the way, definitely feel free to ask anything you'd like. So I'm going to go look at this before I delete this section. I believe that these are just the arguments to this function, and they were originally pulled out as separate variables. There actually is, in this case, these do look like they are being, excuse me, pulled out into variables first, and then the normal clip function is being called. So let me, I'm going to keep going, and then we'll look at that normal clip. We know what the arguments to normal clip are, which is a, we call it a 0.16, but it is actually a 32-bit integer with the first 16 bits used for X and the second 16 bits set for Y. Excuse the beeping if you can hear it. I left my multimeter on. I was attempting to resurrect some 18650s for a Bosch drill, and it's been on a trickle charge for 4 or 5 days and has not survived. I think it's dead. All right, so I think that is probably a reasonable place to start. There is a bunch of other stuff in here that when I was decompiling all these, there may be some of these that are known types. There may be others that aren't. And so it might also be good to go back and just review how these have been used elsewhere now that all of the data is done as well. Okay, so variables are gone. Registers, we can't do anything about. The R in the current column means there's a register difference. Immediate values, we did this on another PSP function earlier. The global variables are given a name based on their address and some additional information that you can configure for Splat. And that's, you can either give them an explicit symbol name, or if you haven't given a symbol name, Splat will kind of auto-generate a symbol name based on their address. And so that makes it hard sometimes to read between the PSP and the PlayStation version. So I went through yesterday and updated a bunch of these so that they, the PSP used the PlayStation symbols. And that made things a bit easier. And so we might go do that as well. Register differences here. So immediate and register differences, I'm not too worried about. Occasionally we'll see this like on line 93 or around line 93, where there is a move basically the contents of the V0 register, which is the return value of this GTE RTPS function, are moved into the V1 register. In this case, that is never used. So I'm not sure why that might be happening. It is possible we could look at the signature here. So there is no function signature for the GT RTPS function call. And so it'll use a default signature that looks like this, where there's an int return type and an arbitrary set of arguments. Occasionally, that makes a difference. In this case, not. So the return type for RTPS is stored in V0, or the return value, sorry, is stored in V0. And so this move instruction is saving off that return type into something else, almost as if it's going to be used later because the next function calls will overwrite that value. However, V1 isn't used again. We could try to add a variable. And the MetroWorks compiler will dutifully assign that and then not use it. I screwed up something along the way. Oh, that's what I screwed up. All these should be implicit. They can be set to values. And so we get the move instruction there. It gets put into S5, which we don't want. We don't want it in a register that's reserved for a variable. So I'm really not sure what might be going on here, because the value's ultimately just thrown away. Hey, Entropy Gravity Well, good to have you. And what's interesting that on line 104, we see the opposite. Our function is causing this V0 to V1 store, but in the original it's not. So why is there a difference? I'm not sure at the moment. Then down here on 115, somewhat interesting, the A0 register is used for arguments. GTE RTPS doesn't take any arguments. V0 is the result of GTE LDVO. That doesn't return anything. We can do something like this to try to fake it, and we get rid of the previous line, we get something that might be similar, but is not quite right. And I was at the wrong one. It would have to do this. So these lines are basically the same. The only difference is that this is happening for x0, x1, x2, x3. So this does give us the right move instruction there, but that's not how this function works. Actually, let me go look to see if we have other code that uses this. I say it's not how the function works, but maybe I'm wrong. I don't want to assume anything that I may have incorrect. Yeah, I don't see anywhere where this is being assigned. And I have the inline ref up so we can see what the pseudo function signature for GT LDVO is. And it's basically a macro with a side effect for the GTE chip, not something that has a return value. So let's go down to line 121, which is the first place that we start seeing differences in the code. So this is a pretty simple change. We can flip the order of these, and that should match now, except for registers. Hope you get something good. Get some chips. Get some, I don't know if I could say what I'd want to be ordering in my groceries based on the YouTubes, what they allow and what they don't. Adult beverages, we'll just say that. Canned sardines. I'm a fan of kippered snacks myself. I probably would like sardines, but there is just a mental block. I can't. I don't know why. I've never had them and don't want to. I like smoked fish, but and no problem with herring or other things like that. So it looks like I screwed this up. This should be a pointer to one of these arrays. I assume that it was a Z, so I need to get rid of that and get my get some pointers. So let's see if we can have an idea of what this does and give it a reasonable name. So this is getting passed to LDV0, LDV0, and that is loading the vertex to register 0. So this is a vertex array pointer. And these are implemented as vectors. So this will be a S vector pointer. And maybe I should name this vertices. Then I'd have to get out a dictionary and learn to spell. I can imagine. Does she also make a lot of like jerk seasoned food and treat gravity well? It's kind of funny how, so growing up, I wouldn't say that we had a lot of Cajun food, but kind of from that area, definitely enjoyed that style of food, and have relatives lived kind of in that New Orleans area when I was very young. That's when you got to give them the spicy food when they're young, then they get used to it. So And I had jerk, like, whenever I'd come across jerk style food in Americanized restaurants, like, I always liked that. And then as an adult, had what I think was real jerk style food. Very different from American jerk style food. Very good. Let me make sure that this 2D0. Gotta say that even though it's fake, I do like American jerk. Kind of like American Chinese food, I guess. Kids are kind of funny in what they will eat and what they won't. Um, one of my boys will eat just about anything. And he doesn't like super spicy things, but he'll try it. And then I have a kid who will eat macaroni and cheese and chicken nuggets, and that's about it. Awesome, Nate the Great. So Nate the Great has been on, and we watched part of one of his arbitrary code execution videos. You can check him out on YouTube. And let me plug you, Nate the Great. And so if you can't read the chat because it's too small, he's working on Total Control Glitch for the Xbox 360 version. We haven't looked at the Xbox 360 version here. I can't remember anymore. I'd have to look at the disc again. There are some. Let me pull it down. So I have the Konami Classics version, and I can't remember if it has a. Yes. So the Konami Classics version of Soten. Let me. Yeah, there we go. Not explicitly says you may not reverse engineer it. However, as far as I can tell, the Xbox. This is not legal advice. This is not anything like that. The Xbox 360 version that you can get through the Xbox store does not have such a limitation. That's my layman's interpretation, just skimming through the license for both of those. So never do I decompile the PlayStation Classics version. Only the actually I've not really touched the Xbox version at all. There's Nate's channel if you want to check it out. Yes, you may take the legal advice, but then you'll have to pay me like a lawyer. Kidding, of course. All right, so there is an OR here that exists in ours. I'm going to take this actually. We have been able to make a little progress here, just a tiny bit. I'm going to take this over to the PlayStation version and see if that has changed anything. I changed it for the worst. That's okay. Automod is strict. We don't allow foul language in my house, but also are not as strict as AutoMod. Okay, so there's a plus 24 here that's happening. It seems like it happens on the PlayStation version, but not the PSP version. Whether that is the case or not, that's part of the offset for this particular scratch pad variable. May or may not come back to haunt us. And now we're back to this area. So normal clip is one of the GTE functions, and it hadn't been, we don't have a decompiled version of it, and we also don't have the declaration didn't exist prior to working on the sword familiar. So it's taking three XY pairs, and the way I'm reading this is that we need to put those into variables, and then those variables will be used as the arguments. So let me go grab that. Yeah, it looks like it's taking a pointer to a point 16. So let's see what these are. I don't have these in this file. These are listed as a new struct, which is a point 16 followed by something else that's unknown. I think that's fine. So let me create 3 pointers to point 16, or sorry, to new structs. Great name for a struct. Anybody excited? The NS makes me think of Nintendo Switch. Anybody excited for the Switch 2? Get this again. Sorry, wrong one. So this is taking a I may have this wrong. So I have this as a pointer to a point 16 as opposed to a point 16 being present. So I'll have to see if that is correct or not. Definitely broke something along the way. Types are hard. Oh. Yes. So if you're not a C programmer, C is a little funny in how you declare pointers. Pointer um, kind of is part of the symbol name, but it's like a sigil in Perl where it has a meaning. So it's part of the symbol name, and you could think of this when the star is there on the symbol, you're referencing the value. Without it, you're referencing the address of that value. And when I'm declaring multiple variables together, I often forget that. I'm not sure what. Oh, I just needed to recompile. Okay, so we are loading this. So this looks like it's actually pointing right to that. So these are going to be 0.16 pointers. And struct access, not pointer access. All right, so how does this look? That looks a bit better. When looking at this, I'm trying to tell the difference between reading values versus reading pointers. It still is unclear to me if this should actually be the XY or not. We'll find out down here actually whether this should be a pointer or not. And it looks like it is. So how we load the address into a register and then load the word from that address tells us that it's a pointer. And it looks like down on line 180, this is going to be a similar situation where we're getting the values first. And I'm just going to reuse the XYZ variables. I don't know if that's correct or not. So these are also pointers. Oh, actually, so we're, let me see this. 9.8 is what's being loaded here. This looks like it's loading the same values. I had an offset of 4, but the um, Okay, so this is loading the correct value now. These actually do look like they are going to be in. Oh no, maybe there are variables as well. So of these three, it looks like so X versus Y, where those are in memory, this is being treated as a 32-bit value. It's choosing the thing with the lowest X value, or the highest X value, so furthest to the right on the screen. Oh, and so what's happening? I'm wrong again. Good to be wrong again. This is taking a reference to the structure. So I'm going to call these, I'm going to rename these P1 through, or 0 through 2, and then keep NS for the others. So let's see how that looks. Somewhat strangely, we're taking a reference to this first field. I don't know why. So it'll have to be cast. But that's how it's reading. And it still didn't. Well, maybe not. Maybe. Maybe it's reading this first. So now we have to do a bunch of casting. So dereferencing this pointer, and then yeah. Okay, so the reason I made this a struct of size 2 was based on or two 32-bit values was based on this. However, that doesn't make sense on the PSP. Could be different between the PSP and the PlayStation, but this is actually much simpler than I was making it out to be. It is just a 0.16 pointer. There's no unknown for here. The Xbox version, we can, so there has been some dumps. The Xbox version is its own compiled for PowerPC version of the game. But as far as I know, except for like the integration with the system, it's the PlayStation version of the game. There's a few differences, but yeah, as far as I know, it is the PlayStation version of the game. I'm trying to think if there's any good function to illustrate that. There have been others. Someone who isn't me has dumped the Ghidra decomp, and so I've seen that. And I've not looked through it too much, but my understanding from other conversations is that it is the PlayStation game. All right, so I'm breaking things. I might need to redo a bunch of this. I'm going to get rid of this for now, just comment it out and come back to it after these data types are figured out. So let's get to line 164, and I just want to make sure that all of this is as expected. So those seem fine. So what this seems like to me then down here, I'm going to just take this. Oh, shoot. It's not fine, of course. It's not. Oh, so the question still remains, is this a pointer to a 0.16 or is it a 0.16 itself? I'm going to I'm going to get rid of this as well. So on line 172, this will tell us. So this looks like a pointer to a 0.16. So this is an array of pointers as opposed to being the 0.16. And so each of these then okay, so that looks fine. And then this looks fine as well. So each of these will have to get fixed to be the right access. And so each of those is generating the right set of instructions. And so now we can come back down here and see what is happening down here. So we don't have the new struct anymore. We're taking, this will be the same, I think we can use the same point variables. Just loading these over and over and over again. And what's going to be different here is that, as far as I can tell, this is taking the next entry in. Oops, I'm Doing this all wrong. The next entry in that array, and so it is going to need to be cast as a 32-bit value. We probably should just add this to our .16 struct, but that would require a lot of changes. And those look good now. So these are appear to be loaded inline and not separate variables, unlike the other ones. So I'm going to do that. Not quite. What is missing is, I think, I see. Yeah, so it's still not quite right, but definitely much closer. Now looking at it again, these may be being pulled out into variables. So let me revert and look at that again one more time. What I'm not getting necessarily is why these aren't being stored directly to the argument registers, and they're making an extra step through a different register. So not sure about that. We'll have to come back to it. Next one is a little easier. We have a 32-bit value that's being loaded somewhere, or a 16-bit value that's being loaded as a 32-bit value. So there's only one 16-bit value in this list, and it was there, and so now that matches. Down on 209. Um, 209, we're seeing the same thing as what was up above. A bunch of moves that seem superfluous. Why they're happening, I don't know. 216. So here we're loading a 16-bit value from 4.8, the VX. 4.8 possibly is a vector 32 instead of a regular vector instead of a S vector. I do have that decompiled already, so we should be able to see what that worked out to be. TT004. And I should tell grep what I'm searching for. Yeah, so it's coming in as an S vector here. Oh, my, excuse me, terminal is frozen. 1 second. Fictional bonus points to anybody who can tell me what the background is. I'll give you 10 seconds. If you squint, you can see it. All right, back here. So yeah, this has been decompiled already as a S vector. And so for the S vector, the first two values would work out as I wonder which Castlevania it could be. They could be treated as a XY. There's some weird behavior that you'd get if you did that. This is not actually loading, though, from that offset. It's loading from V0. And V0 is this VARSP. Never mind. It's, I see what's happening. I think that there is a variable that's missing. This does look like it should be a sine 16, though. And that screws up a whole bunch of other stuff. So what might be happening here? So I'm loading this as a sine 16. That doesn't match. That's fine. I can leave this as a sine 32. So this we have a global that's getting a value that's coming from the, yeah, I was wrong about this. That's coming from the scratch pad. And what I think this is actually is a sine 16 pointer, which would be 32 bits, and that would make our 866C a pointer to a sine 32, or sorry, sine 16, and I only have it in here. What's the background? I don't know if you're joking, Orcam, or not, but what's going on here? For those not playing, or those that didn't figure out what the background is, I will reveal all the secrets. If I can load the right settings, of course. Come on, OBS, you can do it. Every once in a while, I'll open a menu and OBS will just freeze. Okay, you won't be able to unsee it. Oh, it is. It's Alucard. Who would have guessed? It is Alucard. All right, so my guess here was that this was a pointer. So I'm going to change this to a signed16 pointer. And that's going to break all the things. And then down here, what do we want to do? We want to, I'm not sure why a reference was being taken there, but let's dereference this. And then do the rest of the math. I think this matches here. And then down here without the addition. A little bizarre that this one's matching the addition. We'll have to see if that's correct or not. And does this help at all? It doesn't. So let's do this. My guess is that we're loading this this counter here and multiplying by 3. Or 2. Let's try 2. But that doesn't quite work either. All right, so we're loading loading the value 1, which is somewhat interesting. I'm not sure where the 1 is coming from. Let's go back to this. Oh, of course, the 1 is coming from the scratch pad. That's the upper part of the scratch pad. So we are using that value, which is acting as a counter or an I value. Why? I'm not sure. It's really bizarre how this is being done. But it's actually at offset 3. Sorry, we're shifting by 2. So these are something longer, bigger. It's possible that this is an array of so the scratchpad stuff we can only see in code what it looks like. We can't see the layout in memory unless we play the game and look at the scratchpad. So we have to kind of base the size of things off of what the code is doing. So it looks like the size of this needs to be slightly larger. What this is pointing to. I'm going to try making this a S vector and see if that, and then I'll have to go through and change all this again. I can get rid of basically everything below this for the moment. And then I only have to change it one place to test that theory. I think an S vector will give me the size that I'm looking for. So then here we need to choose what field of our S vector. And that field should be we'll try Vx for now. It might not be an S vector at all. It may just be like an array of three things. And I'm missing something. 214. All right, so now let's look at this one. It looks like there might have been a lot of extra stuff. All right, so we need a pointer to this. We don't need that value. And we need to cast the pointer, of course, as a LDVO takes a onside long pointer, I believe. No, S vector pointer. Of course it's an S vector. That's exactly what we wanted. And we already have it. So we have a pointer to an S vector. We are adding the value. So we're loading this value, but we don't want to load the value. We just want the address. And so why this is a load word as opposed to a add IU, I don't know. We can do pointer arithmetic instead. That shouldn't make a difference. So is our we could have a pointer to an array of pointers. I will give that a shot. And then we do want to use subscript. And we're still loading the word, and we don't want we just want the address of this. So let me try one more way. And yeah, I don't like that either. So there's something going on with the addressing that I'm not quite getting. This is a little closer. we want to be taking this loading the address of this and then doing a doing some math based on that. However, that doesn't necessarily make sense with the rest of this. I'll try one more thing, and we'll see if that works. I'm going to make 866C an S vector. That may break this assignment, but it will allow me to take that address. Let's find it. And do the pointer arithmetic. It makes less sense up here, though, to do this subtraction. So that can't be quite it either. Let me see where these are. Yeah, so that gives me the correct instructions. They're taking the address of that and then adding that value. And obviously something. This is sorry. Other parts of this are going to be very wrong then. So I'm going to go through and try to replace all these with that and see how close that gets. Yeah, that is closer, but I don't think it's right. So I will do this. I'll say that this is a pointer. And this is going to break everything again. And so I need to load a S vector pointer here. And doing the math, doing the pointer arithmetic makes sense. Let me see if that math ends up being correct. Not quite. So something much larger than, or smaller than 10. We want the add to be 10. And S vector is size 2. So we need 5 of them? Nope, much less than 5. We'll get it, We just need 2. No, less than that even. So whatever the size of this is, seems like it needs to be a multiple of 10, or but that's not what it is. There's ways to force that. I'm not gonna. I'll make a note here, just saying that this is wrong, and come back to it. What may be happening is a lot of times there are just pointers to like assign 16, and we could be doing that and then casting as an S vector. And so that allows us to do the math on sine 16s, which becomes much easier because we just need a multiple of 2. So taking this address seems to be what this code wants to be doing. Kind of a frustrating yeah, so we don't want to be loading this directly. We want to take a pointer to it. And we're off by 2. So whatever this is slightly larger than drat. Is larger than an S vector. So if I cast this as a S vector 2, I don't think I'm going to be able to cast it that way. I need some way to treat that pointer. So I can cast it, for example, as a vector pointer. And a vector pointer will be double the size. And oh, that didn't. I expected that to. Oh, it's not compiling. That's why I didn't get updated value. Not an L value. Is that gonna work? Oh no, I do need to cast as S vector. Okay, so we have a pointer to a vector array. And that finally matches. Oy. The code matches. I don't think I have the correct intent there yet. So now, no, maybe I'm wrong again. Nope, that's right. Okay. So that matches. Now I should be able to go down and fix these others, which should ideally follow the same pattern. There is an add 1 in here, so this is the next entry in this array. The add 1 needs to be grouped. Okay. I might go up here and just add 0 to keep all of it symmetric. And if anybody's seeing something that I'm missing in chat, please holler. There is something missing. So here we have a shift left by 2, which means that this index should be of something of size 4. So we need to find what type this is. So we have a 0.16. Let's look at STSXY and see if that makes sense. So a 0.16 will be the right shape. Let's get back to where we were. So on 225, wait, all this, all the different data structures and how they get loaded is time consuming and can be a little frustrating. So there's an add here that doesn't seem necessary. The shift left by 2 is happening. The it so there's another value that's being shifted here. Oh, that may be coming from this above. Yeah. Often these conditions are written like this. So a 4 is being loaded. And that 4 is being shifted. I'm going to look at the, can't remember if this had a decomp available. It does. The more straightforward math should come out by the decompiler. Yeah, and so this is how it looks to me too, where get LDVOs return values being put into arg1 and then being passed to RTPS. Yeah, so there's this constant or immediate value of 4 that's being loaded in here, and I'm not sure where that's coming from. I'm going to back this out. What I do want to look at is this is much closer than it was. So how does the PlayStation look? Is it any closer? Not compiling on the PlayStation. So we have a few incompatible assignments. That's because these data types changed quite a bit. And I must have them over in the context. These are all 0.16s now. It's nice getting rid of structures like this that are no longer necessary. 225 is the next error. And we'll just get rid of this from context. Wow. Okay, so what had been done had we had backtracked a bit on the PlayStation side, but this actually helped quite a bit, about 10% closer than it was just a little bit ago. So let's look at this real fast before we go and just see what might be going on. I played with these a couple different ways, and the order of these ended up being different on the PSP side. Let's look at that one more time. So that's on line 123, this else block, and see what might be going on here. Oh, and now looking at it, it is. Oh, I'm still on the I'm still on the PlayStation side. PSP. Let's go. 122. So we can change this. It does change the instructions. There's two things that I can do. I can change this to a not equal to 0. That would be the case if sorry, let me fix this error, and then I'll go back to that. Okay, so explicitly doing a equal or not equal to 0. Oh, am I? Yeah, excuse me. Oh, there we go. F for STZ4P. I will get to your question in a second. Thank you, Orkim, for the screen check. Yeah, sometimes the sometimes window capture just starts failing. Okay, so there's a couple ways you can write these, and I tend to think of them as all logically equivalent. The compiler doesn't necessarily treat them as logically equivalent. So the way this originally was written, and that's why using two compilers, we can kind of get to the truth one way or another. So the first way we could check this, and the way that I had it originally, was the truthiness of the value of this unknown AD variable. truthiness just means not 0. Pretty simple. And we could negate that and we could say it is 0. Or we could do an arithmetic check against that and say not equal to 0 arithmetically, and not just through truthiness. As programmers, I would say that we tend to treat those the same, but the compiler doesn't necessarily. And this is one of those cases where the compiler didn't treat those the same, and let's see if that works out. I might not have flipped those originally. And it still doesn't work. Let's try it that way. And we need to flip them. Yeah, we need to flip them. So finding the right, so there's basically a matrix of 4 ways that could be written, and finding the right way to write it, drat, is can be a challenge. Let's try it one more time, and it's not gonna be happy with us. There is one other thing that might be worth trying, and that's using a ternary operator. And seeing if that changes how this. So that gives us the right. But I deleted my assignment at the end. Yes, yeah, this definitely is a puzzle, and that's the fun of it, is that it's a puzzle. So I have these backwards now. So there's an extra store onto the stack. Cursor going crazy. Okay, so this works as a ternary. Let's look at it again on the PlayStation side and see if that is working on line 122. Still not working on line 122. Flip them. So now we're up to 6 ways that this could be written that are all logically equivalent. This is introducing a jump, which we don't want. So that's going to remain unsolved, unfortunately. I'm going to get it to match here on the PlayStation side, since that's the one that I want. And I'll do the same here. And flip these around. So yeah, it won't be matching on the PSP side, but I'm okay with that for now. And 91 is probably a good place to leave this. How does the compiler compile individual C files from a project and output assembly that has the correct addresses or registers to read from or write to? That is a great question, and we actually have to do a lot of coercing to make that happen. So there's a couple things that are going on. One is by using the PlayStation SDK and using, so they were compiling with GCC 2.6 at the time, using those compilers, and then having custom linker scripts that will link to the correct addresses, as well as manually setting addresses of symbols and other things like that. We can get things to the correct offsets in their bin files, for lack of a better term. That's what they're called on disk, is bin files. And so those bin files are a little different from ELF or I can't think of the Windows ones. Cough, Mach-O, things like that. Those uh, describe a bunch of different sections of code and data and other things like that in the file, and then the linker's job is to put those into memory. The PlayStation is much simpler. PSP, same. For the PlayStation and PSP, you say, here's my file, here's the offset in memory that I want it loaded. Go do that thing, and I can check the progress of whether or not that operation is finished. And once that's finished, so that's the loading screen that you get. Once that copy has completed, then these things are at the correct offset. So some of the tooling that helps us deal with that is Splat, which was originally written for N64, and N64 ROMs are a whole different ball of wax and story. I'm not going to go into that at all. I know very little about it. But for Splat, you can, so you have to do some legwork up front. Once you know where an overlay is going to be loaded into memory, you can tell Splat, these are the offsets of this file where it's going to be loaded. And then you can give it relative offsets for that file, and will help do the translation to where those should be in memory, and vice versa. But then when you build your final thing, those offsets are still relative to that file, except for like globals. Globals keep the global offset values. That may or may not answer the question. But yeah, it's a little tricky, and different from, I think, how we think of loading and libraries and other things like that today. You don't have like the same infrastructure on the PlayStation or PSP that you would with something with a full operating system. So I think that's where we're going to leave it today. This is a relatively hard one, but it is getting closer and closer to completion, and that's nice to see. What makes this function, so this is one of the sword familiar functions. What makes this one a little more challenging from some of the others is that it relies on a lot of these inline assembly macros that are for the geometry transform engine, which is a coprocessor for the PlayStation. Fortunately, we have the PSP version that we can flip back and forth to, where those inline assembly macros become function calls. But then on top of that, we have the scratch pad, which is a area of memory used kind of for temporary things and shared. I believe it's shared, but between the geometry transform engine and the main processor. And the PlayStation has that scratch pad area in place of a memory cache that some other MIPS processors would have. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev and see the progress on various overlays that we've been working on. We've been looking at the sword familiar overlay, which is also known as TT004 on disk. As I've mentioned every day, I'm finally starting to get the PRs constructed to get progress moving on this, and so hopefully we'll see towards the end of this week and especially next week, this going up. I think we're probably around 90%-ish done for what we've done on the stream. And then I think chat, you can chime in, YouTube comments if you guys want to see something specific. We kind of need to decide, are we going to keep struggling through the more difficult parts, the slow going parts of these remaining functions, or are we gonna Oh, why doesn't it let me snooze? Are we gonna keep going? Is it gonna let me snooze? Is it gonna let me snooze? I can't snooze the ads. I'm sorry. That's where I'm gonna end it. I'll see y'all tomorrow.